All right. So our first thing here is we're just going to find the equation of the tangent line at x equals 2. So first off, when you're trying to write the equation of a tangent line, or any line for that matter, what do you need? You need two things. What are the two things we always need? Point and a slope, exactly. I always need a point and a slope. So our point we can get from our original function. So we're looking at x equals 2, so we'll figure out what's f of 2. F of 2 is 4 minus 6 plus 1, so -1. So we're looking at the point 2 comma -1. And to find the slope, we'll use just our derivative to find the slope of the tangent line. So f prime of x in this case is just 2x minus 3. We'll evaluate that at x equals 2, which should give us what? Looks like that's 1. And that's our slope. So we've got our point, we've got our slope, should be y minus -1 or y plus 1 equals our slope m times x minus 2. Easy enough. Hopefully. Everybody remembers how to do that? Here's our graph, x squared minus 3x plus 1, and we got y plus 1 equals x minus 2. And there it is. There's our tangent line to our graph at that point. Everybody good? Easy enough? Okay. Should be. It will get more difficult. Let's see if we can find the equation of the tangent line at x equals 3 for this function. So I'm going to remind ourselves how to find the derivative of the natural log function. We need a point and a slope. We get the slope here by taking the derivative. F prime of x should be what? Derivative of natural log of u is 1 over u. So 1 over 3x cubed plus 5x minus 1. And then times the derivative of u. So that'd be 9x squared plus 5. And if we evaluate that at x equals 3, what do we end up with? Looks like that's what, 86 over 95. Did I do that right? Oh, good. All right. And then to find our point, it should be f of 3. F of 3 is just the natural log of, that'd be that same thing that we had in the denominator there, which was 95. Natural log 95. So our equation should be y minus natural log 95 equals 86/95 of x minus 3. Everybody good with that? And remember, you can leave it in point slope form. No reason to convert it into slope intercept unless you particularly want to. Well, we have natural log 3x cubed minus, was it minus 5, no, plus 5x, I think. And minus 1. And we had y minus natural log 95 equals 86/95 times x minus 3. And there's our tangent right there at x equals 3, 3 comma 4.554 apparently. And we can see that's our tangent line. Everybody good? All right. So let's now do this for a parametric. So we're going to look at x equals t to the fifth minus 4t cubed, where y equals t squared. And we want to find all of the equations of all of the tangent lines at the point 0, 4. So before we even get started with this, let's take a look at the graph of our function. So t to the fifth minus, what was it, minus 4t cubed. And just t squared for the other part. So I'm just going to put on some parameter restrictions there of negative 1,000 to 1,000. I didn't give any restrictions on this, which means that we're talking about for all real numbers of t. But putting on negative 1,000 to 1,000 ought to give us plenty of stuff to see here at 0, 4. So this question is worded a little bit differently than the other ones. You probably note it says find the equations of all of the tangent lines. And so we'll see that our equation goes through the point 0, 4 two different times. So we should have two different equations for two different distinct tangent lines at that point. So different than when we just have a regular old function where we're only going to have one tangent line at the point. Now it's possible to have two or even more than two tangent lines at that point. Everybody see that from the graph there? All right. So question is, how do we figure this out? Well, we need a point and we need a slope. We already have the point, right? We're given the point 0, 4. So all we need is slope. And how do we find the slope of the tangent line for a parametric? Should still be dy dx, right? So what does dy dx equal for a parametric function? To remind ourselves from yesterday, it's dy dt over dx dt, which gives us what? 2t over 5t to the fourth minus 12t squared. Good or no? Okay. And then what are we going to do with this? Any thoughts? We could take out the t first off, right? We could call this just 2 over 5t cubed minus 12t to start. But how are we going to figure out our slope, and how are we going to figure out what t value to plug in here for our slope? Any ideas? What do you mean, kind of put it through the original? Okay, yeah, Alice. So we're going to look for the t value that makes x equals 0 and that makes y equal 4. Exactly. So we're going to take our x value of 0 and say 0 equals t to the fifth minus 4t cubed, and we'll solve that equation. So what can we factor out of that? Hopefully a t cubed, right? So t cubed times t squared minus 4, which tells us that x equals 0 when t is 0 and when t is positive or negative 2. Everybody agree with that? Hopefully so. And we also need to figure out when does y equal 4. So 4 equals t squared, and that's when t is positive or negative 2. And so what we'll do is we'll look at the overlap here because we need both of these things to be true. We need x to equal 0 and we need y to equal 4. So the overlap is on t equals plus or minus 2. And we'll ignore t equals 0 because y doesn't equal 4 at t equals 0. And if we look back at the graph real quick, we'll see that there's 2 places, so that makes sense. T equals 2 and t equals -2. And at 0, when x is 0, there's another place, right? And so that must be when t equals 0. Everybody good so far? Okay. So now we want to know, what does dy dx equal when t is equal to 2? And what does dy dx equal when t is 2? Should be 2 over, what does that come out to be? Let's see, 2 cubed is 8 times 5 is 40 minus 24 is 16. So 1/8. And we'll also try to figure out, what does dy dx equal when t is -2? And that should be 2 over, that'll become a -40 plus a 24, right? So that's going to be -16. 2 over -16 is going to be -1/8. Everybody good on those two slopes? Okay, and we're already given a y-intercept. So as we write this in the form, we can either do point slope or we can just go straight into slope-intercept form. So what should our two equations be? We should end up with y equals 1/8 x plus 4 and y equals -1/8 x plus 4. And there's that tangent and the other tangent line. And we could probably zoom in a little and maybe see a little bit better. But yeah, the red one's staying above the black line the whole time, except at the point of tangency, and the blue one is also staying above the black function everywhere except that point of tangency. Everybody good there? Any questions on that process? Ryan, that's a no to questions, I assume. I'm guessing, not a no to good with it. No to questions. All right. Everybody good? All right. Not too bad, right? Let's do another one. We got x equals sine t, y equals 3 cosine t. We're going to look for the tangent lines at the point √2/2, 3√2/2. So what should our first step be? All right, we can take a derivative first, sure. So taking our derivative should just be dy dt over dx dt. And what's dy dt? Derivative of 3 cosine t should be -3 sine t. And the derivative of sine t should be cosine t. Everybody good there? Can rewrite this as -3 tangent t if we wish. Everyone good there? Okay. And then next thing we'll do is we will figure out at what t values x equals root 2 over 2, and at what t values y equals 3 root 2 over 2, and we'll have to look for the overlap of those. So root 2 over 2 equals sine t. Well, when does sine equal root 2 over 2? When t is pi over 4 and 3 pi over 4, right? And every revolution around after that, but we're going to just talk about this one specifically for t less than 2 pi greater than or equal to 0. So we'll only worry about that interval here. What about for 3 cosine t? We got 3 root 2 over 2 equals 3 cosine t. And when does that happen? At t equals, hopefully, pi over 4 again. And this time, what's the other one? Should be in the 4th quadrant, right? When cosine equals root 2 over 2, 7 pi over 4. And what's our overlap on these? It's just our pi over 4 value, right? We can ignore this, and we can ignore this one. Everybody good there? So we'll evaluate this at t equals pi over 4 to get what? What's tangent of pi over 4? Should be just 1, and so that ends up being -3. And what would our equation then be? It should be y minus 3 root 2 over 2 equals -3 times x minus root 2 over 2. Everybody good there? Let's take a look at the graph. So we've got sine t, and we've got 3 cosine t. And we're going from just 0 to 2 pi. So we've got this nice little ellipse here. And what was our equation? Our equation was y minus, what was it, 3, y minus 3 root 2 over 2. Equals -3 times x minus root 2 over 2. And sure looks like that's our one tangent line there, right? On the interval from 0 to 2 pi. Obviously, this ellipse goes around and around and around. So, I mean, it touches this point an infinite number of times. We could rewrite this, you know, for any angle that we go around here. But the equation's still going to be the same. Slope's still going to be -3. And our point of tangency is still going to be root 2 over 2, comma 3 root 2 over 2. Any questions on that one? No? All right. Now we want to find the equations of all of the tangent lines at t equals pi over 2. So this one's a little bit different. How's this one different? We're given the t value, not the point, so we got to find the point. Probably actually a little bit easier this way. So first, let's find the point. If t is pi over 2, what does x equal? Should be 2 cosine 3 pi over 2 minus 4 sine 3 pi over 2. And y should equal 3 tangent of 6 pi over 2, or 3 tangent of 3 pi. So let's see. What's the cosine of 3 pi over 2? Yep, should be 0. Good, Nick. So 0 minus 4 times our sine of 3 pi over 2. And what's the sine of 3 pi over 2? Should be -1. Good, Darius. So our x value is just going to be 4. And our y value, what's the tangent of 3 pi? Tangent of 3 pi should be 0. So this is just 0. So we're looking at the point x equals 4, y equals 0. Everybody good with that? And so now what do we need? Now we need the derivative to find the slope. So dy dx should be dy dt. And what's dy dt going to be? It should be 18 secant squared 6t. Everybody agree with our numerator there? Everybody good with that? Okay. And our denominator is going to be a little bit longer. Derivative of 2 cosine 3t should be -6 sine 3t. And the derivative of 4 sine 3t with the minus in front should be -12 cosine 3t. Everybody good there? Yeah. Okay. So now we just need to evaluate this at t equals pi over 2. And so at t equals pi over 2, we're looking at 18 secant squared of 3 pi over -6 sine 3 pi over 2 minus 12 cosine 3 pi over 2. And what is the secant of 3 pi? Yep, we got -1 there, right? That's the same as the secant of pi, right? And cosine of pi is -1, so secant of pi is -1. And if we're going to square that, that's going to just turn it into a +1, right? So -1 squared gives us +1 times 18. So we got an 18 in the numerator. And the denominator, once again, the sine of 3 pi over 2 is what? Should be -1. So we got -6 times -1, which is 6. And then minus, and again, the cosine of 3 pi over 2 is 0. So 6 minus 0, which gives us a slope of 3. So what should our equation end up being here? Y minus 0, right, equals 3 times x minus 4. Everybody good with that? Or 3x minus 12 if you want to write it that way. So let's graph all of this here. We had 2 cosine 3t minus 4 sine 3t. And then we had, what was it, 6 tangent 3t? Is that right? 3 tangent 6t. All right. So we got this nice looking graph here. Kind of looks like a DNA or something, maybe. And at t equals pi over 2, we had y equals 3x minus 12. And that's at the 0.40. And yeah, right there, it looks like it's tangent to our graph at the 0.40. Everybody good there? We'll assume that's a yes since nobody is responding. All right, why don't you guys give this one a shot on your own, take a couple minutes, see if you can get this one done, and then we will talk about it in just a bit. How's this coming along? You guys need another minute or two, or are you guys almost done? Yep, sure. All right, we all good now or no? Everybody good? Adrian, you finished there? All right, let's take a look at it. So one thing that we need to do is we need to figure out when x equals -3 and when y equals 7. So to get when x equals -3, we'll just set -3 equal to our x portion of our parametric, which will give us t squared minus 2t minus 8 equals 0. And we can factor that to t minus 4 and t plus 2. So we got t equals 4 and we got t equals -2. Everybody get those two? T equals -2 and t equals 4. Yep. All right. Cool. Then on the other side, we should be setting this equal to 7. So that gives us 7 equals, you know, all of this stuff. Plus the 7. We can cancel out those 7s to get t times t minus 4 cubed minus 3t squared times t minus 4 squared equals 0. And we should be able to factor that out a little bit more so we got no subtraction between terms in there. So from the t and the t minus 4 cubed and the 3t squared and the t minus 4 squared, they've got a t in common and they've got a t minus 4 squared in common. So we'll factor that out, t times t minus 4 squared. And that should leave us with, in the middle here, a t minus 4 and then minus, and then we took out the t from the 3t squared, so just minus 3t. And that should give us equal to 0. That should give us t equals 0, should give us t equals 4. And then this one becomes what, -2t minus 4 equals 0, or t equals -2. Everybody get those three values for the y one, for the y coordinate, hopefully. Okay, good. And so our overlap is 4 and -2, it would look like. We can ignore the t equals 0 value. And just real quickly, I put the graph in here while you guys are working on that. If we look at the graph, we can see there are two places where our graph goes through the point at -3, 7. Right? We got two different places where that, or two different times when that happens, two different t values where that happens. Okay? So it makes sense that we should have two different values there. Okay, so then what do we need to do? We need to find our slope, right? Okay. Yep, so find our slope using our derivative, so dy dt and dx dt. And let's see, we could probably fit that here. We'll see. Our dy dt, maybe we won't be able to fit that here. Let's do this on the next page. I'm going to kind of go back and forth here, but our first part of the y term was t times t minus 4 cubed. And so probably need to use the product rule on that. So we'll have t times t minus 4 squared times 3 times the derivative of t minus 4, which is just 1, and then plus derivative of t is just 1, so plus t minus 4 cubed. So that should be the first part of that derivative. And then we're going to have minus 3t squared. And we're going to minus 3t squared times the derivative of t minus 4 squared, which is 2 times t minus 4. And then we have a minus 3t squared, so we'll take the derivative of that to get minus 6t times t minus 4 squared. Is that what you all got for your numerator? The 7 goes away, it's constant, so its derivative is 0. I know my handwriting's a little messy, but it's a little hard for me to write on the laptop here. Those of you that know me, though, know that it's not any better in class. Okay, and then the dx dt was a lot easier, right? That was just 2t minus 2. So now we got to figure out what's dy dx at x equals, what was it? X equals 4 and x equals negative 2. Let's do x equals 4 first. That one looks like it's going to be a lot easier. So at x equals, or at t equals, I don't know why I wrote x equals 4, at t equals 4. At t equals 4, this first term is 0, this term is 0, this term is 0, and this term is 0. So our entire numerator is just 0. And our denominator is not 0, right? It's 6, so 0 over 6 is just 0. So what's that equation going to end up being? If our slope is 0, it's a horizontal line, the y-coordinate was, I think it was 7, right? So yeah, y equals 7, good. All right, and then for our other one, evaluating that at t equals negative 2, that's going to be a little bit more of a pain. Our denominator is going to be easy. What's our denominator going to be? 2 times negative 2 is negative 4 minus 2 is negative 6. And then up here, we're going to have negative 6 times 36 plus, oh, sorry, 36 plus, what is 36 times 6? 216, right? So plus a negative 216 minus, we're going to have 2 times 12 times negative 6 minus 6 times negative 2, which is going to make that a plus 12 times 36. And what did that simplify out to be? Is that what you guys got when you plugged that in? Hopefully. If I did my arithmetic right there. Negative 24. We got agreement on negative 24 when you simplify the whole thing out? Yeah? All right. A couple of yeses. Good enough for me. We'll say that's negative 24. And so for this one, we're going to have y minus 7 equals negative 24 times x minus negative 3. Is that right? So I think it was x plus 3. So those are our two tangent lines. Let's graph them and make sure they look right. First one I think should be pretty obvious because it looks like we got a local max there, right? So y equals 7. Looks good. And then the other one should be y minus 7 equals, what do we say, negative 24 times x plus 3. And it's a little harder to see that one just because that function is so steep right there, but you can see that that purple line now almost is almost perfectly overlapping our function there. If we zoom out enough, we'll see that it does veer off from it, but it sure looks like it's tangent to that curve at the point negative 3, 7. Good with that? Everybody feel okay about that? Other than it just being sort of a long and convoluted process a little bit. Welcome to life, a long and convoluted process. You're right, Darius, that was fun. Looking on the bright side, I like that. That was fun. I enjoyed that. Even though I couldn't watch you struggling like I normally would in the classroom, it was still fun. I knew you were all sitting there working feverishly. It's great. All right, let's do this with polar now. So we want to see if we can find the equation of a tangent line when theta equals pi over 6 for r equals 2 sine 3 theta. So once again, what do we need for this? We need a point and we need a slope. Okay, so we can find our slope the same way. How do we find our slope? Taking the derivative dy dx. And so if we're looking for dy dx here, we'll need to write out what x is. X is 2 sine 3 theta times cosine theta. And what will y be? Y will be 2 sine 3 theta times sine theta. And we should be able to use those two values, x and y, to also write out our actual point. So you guys want to do the point or you guys want to do the derivative first? Let's see, whoever responded first. Point. All right, Ryan, we'll do the point first. Sounds good. So we'll evaluate each of these at theta equals pi over 6. Okay. So at pi over 6, this becomes the sine of 3 pi over 6, or the sine of pi over 2. Sine of pi over 2 is 1. So this is 2 times 1. And what's the cosine of pi over 6? Root 3 over 2. And so our x value just ends up being root 3. Everybody good with that? Hopefully. And our y value is going to be 2 times the sine of 3 pi over 6, or 2 times sine of pi over 2, 2 times 1 again. And the sine of pi over 6 is what? A half. So 2 times a half just gives us 1. So the point we're looking at here is the point root 3 comma 1. Everybody good with that? Now for the less fun part, finding that derivative. So dy d theta, our numerator of dy dx, should be 2 sine 3 theta times cosine theta, first half of the product rule, plus, and then this one's going to become, we take the derivative of 2 sine theta, that's going to be 2 sine 3 theta, that's going to become 6 cosine 3 theta times sine theta. Everybody good with the numerator there? Okay. And our dx d theta will be 2 sine 3 theta times negative sine theta. So we'll put a negative out in front and negative sine theta there. And plus, we're going to have a 6 cosine 3 theta again and a cosine theta. Everybody good with the denominator? All right, and so dy dx at theta equals pi over 6 should be what? We already know that the sine of 3 theta is going to equal 1 every time. So we got 2 times 1 times our root 3 over 2 plus 6 times, now we're looking at cosine of 3 theta, which is the cosine of pi over 2. What's the cosine of pi over 2? 0, so that's going to cancel out conveniently. And we're going to have the sine of pi over 6, which is a half, but that whole second term is going to be 0. And in the denominator, that whole second term is also going to be 0, right? Because of the cosine of pi over 2. So we can write that out. And then we got 2 times our sine of 3 theta, which is 1, and our sine, which is a half sine of theta. So effectively, we've just got root 3 over 1, or just root 3. Everybody good with that being our slope? Did I miss? Oh, I missed my negative out in front. Yeah, sorry. Negative root 3. Good? All right, so what's our equation? Should be y minus 1 equals negative root 3 times x minus root 3. And if we go in and take a look at our graph, what do we have? 2 sine 3 theta, is that right? Y minus 1, is that right? Equals negative square root 3 times x minus square root 3. And sure looks like that is a tangent line, and it's at theta equals pi over 6, right? That looks like about pi over 6 coming out there where those touch. Everybody good there? Any questions on that? All right. Let's do another one. Why don't you guys give this one a try? Give this one a try on your own real quick. So what does the graph of this look like as you're working on it? Should be a limacone, right? What type of limacone should it be? It's like you've forgotten or just trying to work on the problem and ignoring me. That's right, it should be a cardioid, even though nobody said that. Because the ratio between the A and the B value is 1. Since it's positive cosine, the larger part of it should be in the first and fourth quadrants. I feel like it wouldn't be my class if I wasn't rambling at you while you were trying to do work. Normally it's about something unrelated, but at least today it's about math. Is it Monday, Darius? No, there's no way it's Monday. I feel like I've been teaching all week almost already. I think it's Thursday. Yeah, it's Thursday, Darius. Don't mess with me like that. Is it Wednesday? Nah, my computer says it's Thursday. It's definitely Thursday. I usually don't know. Ooh, I wonder what this will do. I never really like learned all this Zoom stuff. I'm gonna see what this does. Let's see. Oh my God. Can you guys still see the problem? Oh, good. I started clicking stuff in the Zoom meeting and now I can't see the problem or Desmos or anything. I don't know what happened. You guys almost done with this? Almost. All right. Not getting through as much today as I was hoping to. I don't think we're going to finish all of these notes. Are we ready? Another almost. Another almost. Just write this up here real quick while you guys are finishing up. I'm sure you all at least did that part, right? Got our x's and our y's. X is 2 plus 2 cosine times cosine, and y is 2 plus 2 cosine times sine. And if we're going to evaluate both of those at theta equals pi over 4, cosine of pi over 4 and sine of pi over 4 are both root 2 over 2. So this is going to be x equals 2 plus 2 root 2 over 2, so 2 plus root 2 times root 2 over 2. And y is going to be, looks like, the exact same thing, right? 2 plus root 2 times root 2 over 2. And if we distribute that root 2 over 2 through there, that might make this a little bit nicer looking. 2 root 2 over 2 is just root 2. And then this becomes plus 2 over 2. So root 2 plus 1. And this will be the same. Everybody good with x and y? Those are the values you got for x and y, hopefully. All right. And then our dy dx. So dy dx, our dy d theta should be 2 plus 2 cosine theta times cosine theta plus sine theta times the derivative of 2 plus 2 cosine theta, which should be negative 2 sine theta. So really we could just make this plus a negative 2 sine squared theta. Everybody good with that part in the numerator? Yeah, okay. And in the denominator, we should have 2 plus 2 cosine theta and times our derivative of cosine, which is a negative sine theta. And then we're going to have, again, a negative 2 sine theta. And this time times a cosine theta. And I think it might be easier if we simplify some of this down first. So we got 2 cosine theta in the numerator plus 2 cosine squared theta minus 2 sine squared theta over, and then down here in the denominator, we got negative 2 sine theta, and then we got minus 2 sine theta cosine theta, which is minus sine 2 theta, minus another sine 2 theta. So what do we end up with if we simplify all this? This is 2 cosine theta. And then what's cosine squared theta minus sine squared theta? Should be cosine of 2 theta. That's one of our double angle identities. And then down here, we should have negative 2 sine theta minus 2 sine 2 theta. So if you didn't simplify it down, that's not a big deal. But it might make it easier as we're plugging stuff in. In fact, I think it will. So let's evaluate this now at theta equals pi over 4. So we got 2 cosine pi over 4, which is 2 root 2 over 2, or just root 2. And then plus the cosine of pi over 2. What's the cosine of pi over 2? Should just be 0, right? And then in the denominator there, we're going to have negative 2 sine of pi over 4, so negative 2 root 2 over 2, or just negative root 2. And then the sine of pi over 2 is 1, so we got minus 2 times 1 minus 2. Is that what you guys got for your slope? Cool. Fair amount of arithmetic and trig values, but not too bad. Y minus root 2 plus 1 equals root 2 over negative root 2 minus 2 times x minus root 2 plus 1. Good or no? Amazing. That's right, Nick. It is amazing. That is right. So y minus root 2 plus 1 equals, now I don't even remember, what was it? Square root of 2 divided by negative square root of 2 minus 2. Is that right? Hopefully that was right. If that's wrong, somebody tell me I'm writing this in wrong. Just doing this from memory here. My graph looks perfect. It looks perfect. I must have done it right. Yeah, and amazing and fun. That's right. Yeah, and there's our tangent line at our theta equals pi over 4 value. Right? If we come out at pi over 4, right. Looks like that's right where we should hit, right? Looks good, yeah. Everybody feel okay about that? Any issues with that? Pretty much out of time here. We got like 5 minutes left. We have the idea we need to do another one of these with polar. Are you guys good? Concept I don't think is too difficult. It's just the process takes some time. All right, cool. So we're going to stop there then for today. Tomorrow we'll finish talking about horizontal and vertical tangent lines. So let me take a look real quick.